Hey, welcome back. We are going to be discussing the second part of our Aerospace Dimensions Module 2, Chapter 1. The last time we met, we specifically talked about engines, and this time we are going to jump right in and we are going to talk about instruments and GPS. This is going to be a shorter lecture. I believe the last video went about 30 minutes. I expect this video is going to go about 15 to 20 minutes. With that, let's jump right in. Okay, so our outcomes, same as last time. We want to explain how reciprocating engines work, identify the parts of the engine, describe how a jet engine operates, identify basic cockpit mounted power plant controls, as well as identify the basic flight instruments. But for today, we are going to simply focus on identifying the basic flight instruments. If you are interested in learning about the other aircraft systems previously mentioned, go ahead and take a look at our previous video. This is a two-part video series, and there is another video out there specifically talking about engines. So if we take a look at the old way, quote unquote, of doing things, we have our analog six-pack. And then if we look on the right-hand side, we will see our brand new fancy dancy glass screens. Most of us older folks, most of our older pilots, we have learned to fly on the six-pack. We're going to talk about that first. The six-pack, if we go around, number one, that's our airspeed indicator. Tells us how fast we're going. Number two is the attitude indicator. It gives us kind of our artificial horizon. Number three is our altimeter. Tells us how high we are. Number four is our vertical speed indicator. Tells us how fast we're going up and down. Number five is our heading indicator, and that'll tell us our rough direction of which way the airplane is heading. And then number six is our turn and skid indicator. Okay. Now all this stuff requires power. So power is very important. If you don't have power, then a lot of this stuff isn't going to work. And so in order to get that power, what you're going to do is you're going to take a little bit of the energy away from the engine, and you're going to basically attach what's called an alternator. Now this alternator is basically a motor in reverse. So you're going to take the engine, it's going to have a belt that's going to be wrapped around. You can see the very front of the alternator here. You're going to put a belt around this that ties it to the engine. And when the engine is spinning, it will spin this rotor here, and then that will spin the stator. So and the rotor inside is what's actually going to spin on us. Now, this operates the opposite of a motor in that when this is spinning, the magnets create a charge. And so this charge then gets sent to the bus of the electrical system, and that is actually what powers your system. So if you have a problem and you can't get power here, the problem may actually be with your alternator. So also, while this is running, you're not going to be taking power away from the battery, as long as you aren't using more power than what the alternator is giving you. Typically, when you're flying on the airplane, you can actually see there's a little gauge, and you can see that there's a slight positive charge coming from the alternator. And that means that it is recharging your battery. Obviously, when the airplane engine is not running and you turn on your master power, then you are going to be taking power away from the battery. So you have to replace that. Otherwise, when you land, you won't be able to restart your engine if your battery's dead. Okay. Moving on. Again, we already went through these, so I'm not going to read them again, but this is your six-pack of instruments. The gyroscopic instruments specifically are the attitude indicator, heading indicator, and turn and skid. You need to know that. The pressure instruments are the airspeed indicator, altimeter, and the vertical speed indicator. Okay. So first of all, I want to give a special credit here. Usually we don't have a production team that creates graphics for us. We try to use graphics that are available on other YouTubers, other websites. And this site, ERAU Special VFR, created the next couple of videos. Really did a fantastic job. All right, so the first thing we want to know about is with gyroscopes. Now, I have a special lesson just on gyroscopes. We're not going to do a 45-minute lesson on gyroscopes here for you, but there's two things that I want you to know about that are important for your test. Number one is rigidity in space. The second is gyroscopic precession. Rigidity in space. What that means is when a gyroscope is up to full speed, it doesn't want to change its direction. It wants to stay in the same general orientation as when it is spinning. That is fantastic for us because what that means now is we can measure that. And even though the airplane is moving all around, or spacecraft for what it's worth, but when the aircraft is moving all around, that rigidity in space gives us something to measure against. And then the second thing we want to remember to know about is gyroscopic precession. Again, this is an entire lesson, but just really quickly, what a gyroscopic precession means is as the wheel is spinning, as a gyroscope is, say, spinning like this, the movement is going this way. And so if I were to push here, then it's actually going to act like I'm pushing there. And so that's pretty nice. Again, if you're interested in gyroscopic precession or gyroscopes in general, it is a fascinating topic. It is actually one of my favorite things to talk about in aerospace, believe it or not. And I have an entire lesson on that, so go take a look for it. Okay. But with those two things understood, we can now look at different indicators. Again, big credit out to this channel, which created these graphics. So the first thing is the attitude indicator. That's pretty much everybody looks at most of the time if they're flying. I'm an instrument-rated pilot, so I use that all the time. And so what happens is that gyroscope is spun up flat, and then since it doesn't want to change position, as you are moving all around, then that gives you your artificial horizon. Now you have individual markings on the indicator itself. So if you're making left or right, you can tell pretty accurately if you're going 10, 20, 30 degrees. That's what those are here, as well as your artificial horizon. Now, this is a good indication of what's inside of the attitude indicator. It is a gyroscope, so as you're moving all over the place, the gyroscope that's in the middle stays stationary. So all of these things that are moving all around, the gyroscope is not moving. So that's important for you to know. The next thing is your heading indicator. Now your heading indicator, instead of, let me pause this for a second. Instead of the heading indicator, the gyroscope being flat in the same way that the artificial horizon was, now we're going to take it and we're going to make it vertical. And so now since we're vertical, we can move around it 360 degrees, and we can measure where that gyroscope is. And so what we do is there's a little knob on the bottom, and we will adjust. There's a magnetic compass that's in the aircraft someplace, and we'll turn the knob until the instrument reads the same direction as when the magnetic compass is reading. And then once we have that, we can actually use that to very accurately keep track of the direction that we are heading. Now, it's not a perfect device. There is small deviations that are introduced over time. So if you were to fly, say, 2 or 3 hours with this and you were on an older instrument, it would probably be telling you you're going in a different direction than you're really going. So the rule of thumb is that roughly every 15 minutes, you want to push that in, as they're showing on the screen, and you want to reset your heading with the magnetic compass. Very important. You don't want to be lost because you're 20 degrees. You're going 20 degrees in a different direction than you think you're going. And again, there we can see that the gyroscope is spinning vertically. Okay. All right. Your last gyroscope instrument is going to be the turn indicator. So the turn indicator is going to actually tell you how fast you're making a turn. It is not the same thing as your artificial horizon. It moves a little bit slower, the artificial horizon, but it's used to be able to control how fast you're turning. So if you want to make a nice, easy 360-degree turn in 2 minutes, you can just line up your wing with the mark. Now, every plane has some different marks. The majority of airplanes have a 2-minute mark. There are some airplanes that have a 1-minute mark. The second thing is the inclinometer. So the inclinometer is just a glass tube that has a ball inside of it, and it shows you if you're slipping or skidding. And so the saying is that you want to step on the ball. If you're going a coordinated turn, that means you have a nice, easy turn, and the airplane is staying on the same arc as the turn. If you were slipping, the plane would be sliding to the inside of the turn. If you are skidding, you would be skidding out of the turn. And so we want things to be nice and easy, especially if you have passengers. You want the passengers to feel nice and easy inside the aircraft. You don't want them being really thrown to one side or of the airplane or the other. If you're slipping, they would feel like they're falling in. If they were skidding, they would feel like they're getting pushed out. And so just to, it's good habit. If you're going to get your pilot's license, it's really good habit to day one, really pay attention to keeping the airplane coordinated and making sure that that ball stays in the middle. I can tell you after you've been flying for a while, it's really going to be second nature. Your feet are just going to work that rudder. You're not even going to think about it. If you're somebody who drives a car, do you really think about how far you're pushing the gas pedal? You just kind of know, okay, I got to go 60 miles an hour. Your brain just knows how far you have to push the gas pedal in. And flying is going to be the same way for that. There's actually a really great book for those that are interested. I'll do a review on this later, but that's called Stick and Rudder. And so everybody focuses when they're learning initially on the stick. The rudder is just important. So got to step on that ball. All right. So moving on. The next thing we have to talk about is there's three instruments that rely on pressure. And so without doing a very long lesson on pressure, basically if you look at the Earth and if you were to be able to measure all of the particles pushing down weighed together, a 1 inch square would weigh 14.7 pounds. And so if somebody says, I'm as light as air, well, guess what? Air actually weighs something. So air is not all that light if you were to weigh it. So 14.7 pounds if you're taking a test, that is a number I want you to remember. And approximately half of the atmosphere is located below 18,000 feet. So as you get above 18,000 feet, the air gets thinner and thinner. Okay. Now, if you are measuring this in an aircraft, you'll hear it say 29.92. That's standard for air pressure. And so let's say you were at an airport and they said, pressure is 30.02. Then that means that inside of this glass tube, if you were to measure it, the pressure from the outside atmosphere would be pushing down. And then that would force the liquid up into this tube, and it would reach a height of 30.02 inches. You don't need to know how to do that if you're flying an airplane, but you need to know what it is when you're going to take off, because it is very important. You will actually set your altimeter, which is right here. You will see, if you see in the window here, you'll see it where it's 29.9. It looks like it's pretty close to 2. For demonstration purposes, they probably did set this to 29.92. So when you set it, one of the ways that you can tell if it's right or not is if you know the field elevation of where you are. So for instance, this field elevation is about 92 feet. It's close to sea level, 92 feet, give or take. And so all of a sudden, and that's the other way too, if you actually didn't know what the pressure was. Let's say you're working at a small field, you're on a grass strip someplace, you're at a pancake breakfast, you don't know what the pressure is, but you know the height of the airport, which is on all of your sectional charts. You can go ahead and you can set this knob. You can keep turning it until the altimeter shows the same altitude as the altitude that you are at when you take off. Okay, so now outside of the airplane, there is two devices. You have what's called a static port. You probably can't read that, but here's your static port. It's a small little hole. It only lets a certain amount of air in and out. And then over here is usually underneath the wing, you have a pitot tube. And so what happens is the air, as you're flying, gets pushed in here, and that creates a difference in pressure between what's the air being pushed in, high pressure being pushed in, versus your regular outside pressure. Now, your static port is typically located on the outside of the aircraft. It's typically on the fuselage, about 2/3 of the way back. Some airplanes, depending on what you're flying, this static port can actually be on the inside. One of the benefits of it being on the inside is that if there's icing or snow or bugs or something on the outside, you don't have to worry about it getting clogged. But you do have to make sure that if it is on the inside and it's an area where you might have baggage, that you make sure you don't put something next to it. If it's on the outside, as it is in most of the Cessnas type aircraft that we fly in CAP, you want to make sure that there is nothing that's blocking that air. You want to make sure that no bugs try to make it a home or something like that. So now what you're going to do is you have 3 instruments that utilize air pressure. So the airspeed indicator, it's going to take the reading from the outside air that's being rammed into your pitot tube, and it's basically going to be able to measure that against the outside pressure to see what the difference is, and that's going to give you your airspeed. Here's one really important part. If you were in some type of an aerobatic aircraft and say you went vertical with it, well, now your pitot tube is going to be vertical, and if you're still moving this way, it's not going to know your airspeed, right? Because it relies on the airspeed pushing into it. So that's actually really important. That, depending on if you're on a specific type of angle, you may have very small deviations in what the airspeed indicator is going to tell you, based on how much air is actually being pushed into that pitot tube. Now, in general aviation aircraft, it is very minor typically, so it's pretty easy to rely on what you're going to see on the airspeed indicator. The altimeter, which is down here, it's the bottom one, that's going to tell you how high you are. So that's going to tell you the difference between the static air pressure that's coming in through that static port as well. And then inside of here, there is a pre-blown up balloon. And so that pre-blown up balloon has the same pressure in it all the time. And so the outside pressure, as it gets lighter, that balloon expands. It takes up more space, and it has a little dial. And as the balloon gets bigger, the dial makes your altitude higher. When you descend, the pressure will get more, and it will push in. It'll make that balloon smaller, and then it'll read you going down. And again, this is why it's important, since that balloon, it knows nothing about life other than what it was calibrated for in the very beginning. And so you want to make sure the way you change that default is by setting this pressure right here with this little knob. The next thing you want to do, last one, is the vertical speed indicator. This is similar to altimeter. The difference is that there's actually a small hole in the device, and that lets air slowly come in and slowly go out, which gives you a slow movement of pressure instead of a very rapid, immediate pressure. And so what that does is it gives you your vertical speed. And so if you see you want to hold a 500 feet per minute climb, you would want the needle to indicate 500. You may have a situation where the aircraft, even though the nose is up, the aircraft might be descending. There was a very famous accident a couple of years ago where an F-22 Raptor pilot actually got too slow. And even though their nose was up, they actually descended back onto the runway, and the airplane and the pilot were okay. I mean, there's some damage, I'm sure, to the airplane, but they had lifted up their landing gear. Their nose was high, but the airplane went down. So it's not always good to just think that, I got the nose up high, so I must be climbing. So it's really important to take a look at that, the vertical speed indicator. That'll tell you really if you're going up or down. Okay. Again, like I said, this is a short lesson. We're only about 18 minutes into it. We're going to try to finish up here in about 20. So, all right. So glass cockpits, that's all the rage. All the newer aircraft, this is what you're getting. It used to be that you had to pay a lot extra money to get the glass cockpits. And now this is kind of like what's coming in default. And so you take all that information that was in those 6-pack of instruments, as well as a lot more information, radio frequencies, navigation, communication, engine information, just everything you can think of that the airplane could measure is being added to these glass screens. And it's taking all this information and it's putting it in a manner that is really easy for the pilot to digest. It makes the workload of the pilot a lot less. It makes pilots less tired. Now, one thing I do want you to note is over on the left-hand side. Get that started. If you look on the left-hand side, there's actually still 2 instruments. You still have your speed and you still have an artificial horizon. They do that because if you ever had a computer problem, either power or some type of glitch on the screen, you want to have some other way of flying. If you are flying visual flight rules, probably not a big deal. You could look outside. But if you were in the clouds and that glass cockpit went dark on you, or it started telling you things that weren't real, that would probably be a bad day. So you wouldn't have any reference to be able to see what's really happening with the aircraft. And so they provide those extra instruments as backup. Okay. Okay. And I think lastly, we're going to talk real quickly about GPS. So we have another video on GPS. So if you're interested in learning more about GPS, please go take a look at that video. But just super quick, GPS was started in 1973 by the Department of Defense. It is currently operated by the Air Force. And what it does is it triangulates. So if you have clear sight to 3 or 4 of these satellites at once, what it does is it takes a look at the time. It knows what the exact time is, and so it measures how long it takes to get from the satellite to you. And when it gets that information from 3 or 4 of these satellites, it can pinpoint exactly where you are. Now, this has gotten so good that it is now down to less than a foot. If I remember correctly, it was like 11.7 inches. It's very close to a foot, but it is amazing that you can have something in your hand. Most of you have it today. Some of you might be watching these videos on cell phones or an iPad that has GPS. And so it is amazing to me that you can tell where you are within a foot, basically. Now, there are 24 satellites in orbit at any given point in time. They are at, give or take, 20,000 kilometers. And they orbit the Earth once every 12 hours. All right. So those are good. That's a good thing to know for your test. 24 satellites, 20,000 kilometers, and they have 12-hour orbits. Now, I did lie to you. I thought this was the last slide, and I forgot. We had one other quick one for you. So the last one, I believe, promise, is the ELT, the Emergency Locator Transmitter. And so this is basically a box. Now, this is not, I always like to call this a black box, but it's not a black box. It doesn't record audio, doesn't do anything like that. But this is your helper. So if you were to land hard or crash or, something bad happened, there is basically, they do it differently nowadays, but there used to be a weight that was inside. And if you hit, the weight would have enough force moving forward that it would hit a switch. The switch would turn on a radio transmitter. So now there are 2 ways that you can do this. You can actually turn it on. If you look here, you can turn on the ELT with a switch inside. So let's say something bad did happen and you want to ensure that the ELT is going off so somebody's coming to help and look for you. You can manually turn on the ELT with that switch. The other thing, but again, it is really designed to be able to indicate if there was a lot of G forces enacted on that box. Again, if let's say you were one of our cadets, you weighed 100 pounds, and say you had a 30 G impact. Well, that 30 Gs, you weighed not 100 pounds, but 30,000 pounds for that very short amount of time at the impact. And so that's what would cause the ELT to go ahead and turn on. Now, the ELT used to be, and we still have a lot of older aircraft that do this, it's just a radio transmitter. And so you can't really tell much. And we have these really funny looking antennas. They look like an H for an antenna. And Civil Air Patrol is actually one of the organizations, not the only organization, but it's one of the organizations that really goes out and trains on how to do these direction finding missions. So if there is an ELT, satellites will actually notify the Air Force, hey, we hear an ELT. Or other aircraft can hear an ELT going off and then notify the FAA, hey, we hear an ELT over here. And then typically CAP will get called out, and we can go out and look to see if we can find out exactly where it's coming from. Now, the good thing is with our newer ELTs, remember I told you we have GPS that actually goes down to a foot. It used to take Civil Air Patrol a long time to be able to triangulate where an airplane is because we didn't really know. We just kind of try to triangulate exactly where the radio frequency was coming from. But now the new ELTs actually provide a GPS signal inside of them. So you can tell exactly where that airplane is very fast. Okay, that is it. Again, we go through this every video, but if you are taking your test, go ahead and read your material first. That's what we recommend. Then we recommend you to watch these video series just to reinforce what you've been reading, fill in any gaps. And then we want you to do any of the hands-on exercises that are in the book. Those are really what's going to give you the ability to really lock in the information you're learning. And then lastly, reread your notes and take your quiz. One thing I will ask, if it is possible, I would really appreciate it if you did like this video and subscribe to the channel. That greatly helps. It makes it easier for other people in CAP when they do a search for this material. It makes it easier for them to find it. It'll help the Google, YouTube algorithm. So if you can, go ahead, like this video, subscribe down below. There's a little bell icon if you want to know when new videos are being released. You can hit the bell icon. The other thing I would also ask is that if you take your test and you do great on it, which I know you're going to, go ahead and leave a message on these videos. Say, hey, I'm with such and such squadron and I passed the test. And, we'll send you a quick congratulations message. Maybe we'll even include a congratulations message on one of our future videos. And we do have an AE Live video series that we produce. And so that's it. So if you are now complete with Chapter 1, feel free to move on to Chapter 2, and we'll see you soon. Thank you so much, and I hope you all have a great day.